as well as a copy of the slides of the webinar. They will be sent to you by the marketing team. Once the webinar has concluded, we are recording the session. As such, everyone who has has registered for the webinar, they will be able to receive the recording for the webinar, and they will receive both of these in their emails sent to them by the marketing team. So today's webinar in the Doctor of Engineering Toolkit, it is Artificial Intelligence and Machine Learning. This webinar will be presented to you by Professor Akhtar Kalam. Some housekeeping rules. Kindly note that if you have any questions, please note them down in either the Q&A section or the chat box. We will have a Q&A session at the end of this particular webinar, and Professor Kalam will answer your questions. If you're familiar with EIT webinars, you would know that our questions are normally answered by the professor at the end. However, as this is a Doctor of Engineering webinar, you have the opportunity to communicate with Professor Kalam at the end. If you have a question, please note it down in the Q&A section and ask that you'd like to speak or have a question for Professor Kalam at the end, and then I will give you presenter rights so that you're able to speak to him and ask your question. Then after I will mute you once more, and then the professor will be able to answer your question. So as I've mentioned, please make sure to note your questions in the Q&A box or the chat box, and then I will be able to assist you there. If you have any other questions that are relating to EIT, its webinars, or the courses that we have on offer, please make sure to leave them in the Q&A box or the chat section, and I will be sure to answer your question. Professor Kalam, would you like to take control of the slides so that you may start with your presentation, please?
Yes, I will, but there are a few people waiting in the lobby. Could you allow them to come in, please?
Okay. No problem. I see that. Please note any questions. Please write them down. Unfortunately, we will not be giving you presenter rights at this moment. Presenter rights will come at the end of the webinar. So questions should come in written form until you ask your question to Professor Kalam relating to today's topic. Thank you, everyone. I do believe I've admitted all the people who were in the lobby. You may go ahead, Professor Kalam, and take control of the slides so that you're able to start your presentation.
Thank you very much, Persia, for introducing me and the presentation. First of all, this is a series of presentations. This happens every Thursday, first Thursday of the month. And so irrespective of whatever it is, unless and until you hear from EIT, you take it for granted that every Thursday, first Thursday of the month in this time, we normally have this seminar, this webinar. We call it Doctoral Toolbox. So I'm just waiting for Tim Lowe to get in, and as soon as he gets in, I think we will be able to. Tim Lowe is still waiting. Siposha, could you allow him to come in, please?
I think he is having some issues because he hasn't. I haven't got the option to add him in. But once he is,
but I've just see. Can I just? I'll try and admit him. Let me see if I can get it.
Sure.
Yeah, it's saying admitting now. I press that.
Thank you so much, Professor Kalam.
It's trying to admit him. I don't know what the hell is happening, but.
Yeah, I do believe that he might be having some networking issues, and that might, there we go, that might stop us from admitting him. But I have also clicked it. It should be good to go, but feel free to start with your presentation. Remember, we're recording the session, so he'll be able to get back to the presentation in the recording.
Thank you very much, Prashu. Thank you very much. Now, just to introduce myself, for those of you who do not know me, I work at Victoria University and Engineering Institute of Technology. I've also worked in Texila College, where I'm the academic director and chair of the academic board. I have my own consulting company, and I'm editor-in-chief of AJEEE. I've published more than 600 papers, more than 50 research students, PhD students have graduated. And you'll be surprised that we already have 2 DEng students. One has already graduated and the other one is going through the examination stage at the moment. So we have got some success in DEng students. 6 of them are enrolled with me at the moment. Uh, I got my PhD from University of Bath, and most of my, not most, all my qualification is in electrical engineering. My first degrees are from India and United States. I got my master's, and then I did my PhD at Bath. I worked in between for 2 years at Iraq. Coming back, I just want to move my slide. And
Professor
coming
Kalam,
back to today.
I apologize, did you take control of the slides, please?
Yes, I have. Can you see the slide moving?
No, I do not see it on my end, but let me just verify. Guys, please tell me if you're able to see Professor Kalam move to slide 5, which is our agenda for the day. Once you're
I'm
able to do so, once you've responded to us, we'll be able to continue with the presentation. I just need to, for you guys to confirm if he is on slide 5 on your end.
haven't heard from anyone. Can someone tell us that you can see the slides?
That we are on slide 5?
Matutang can hear, but they cannot see the slide. No, the professor is not in control.
Okay.
I don't have the control.
Okay.
Can you move the slide, Shipushu? I think it's the same problem we had once before last year.
All you need to do, Professor Kalam, is on the top, in the ribbon on top, where we have the people Q&A and chat function, there is an option for you to take control right there on the ribbon. Please just take control from your end and you'll be able to move
I just give me 1 minute.
Sure. There we go.
Now I think I have control.
You definitely have.
Can you see slide number 5, please?
Yes, Professor.
Okay, and just to make sure, this is slide number 6. Can you see that too?
Yes, the Wright brothers airplane.
Yeah, lovely.
Thank you.
Now, if you look carefully, my friends, I am going to talk about completely a new topic today. This is machine learning and artificial intelligence. Everyone is talking about this, machine learning and artificial intelligence. With Meta coming in and chat box there, there's so much things which is happening, and the Chinese have just floated DeepSeek, and DeepSeek, which is much more stronger than chat box, that has come in too. So you can understand that there is a lot of information, and in fact, there is a lot of things happening today in the scene of artificial intelligence and machine learning. You'll be surprised that artificial intelligence and machine learning is not only being used in medicine or in other areas, but predominantly in engineering. Engineering is dramatically, there is a use of artificial intelligence. So this is really a very big breakthrough. And let us see where we were and where we are. You understand, if you look at, this is the slide that I'm showing you at the moment on my left-hand side, is what was the first flight in 1903. Today, we have got the passenger plane. The largest plane is A380, the largest aircraft, and that's what it is. So look at it carefully, okay? Just 1903 to 2025, just over 120 years, and that is the type of change which has come. So things are moving, and things are moving fast. So now the question is, what is artificial intelligence? What is artificial intelligence? And let's try and answer this question. My first question is that what is intelligence? And before going to artificial, let's see what is intelligence. How do we define intelligence? Is it having consciousness? If it is just consciousness, what about animals? You know, dogs. Dogs can sense you, so they are conscious too. Do they have intelligence? That's a question that you have to ponder on. Is intelligence solving complex problems? If that is the case, what is a complex problem? Definition of something complex depends on who you are asking the question. Is it making the calculation difficult that is making the problem complex? Or is it the recognizable objects which is making the problem complex? Is it making abstractions and getting results out of it? How am I going to gauge intelligence? How am I going to say that one of you is much more smarter than the other person? How? It's very hard. It's very hard to quantify intelligence. So much for intelligence. But let us see what is like when something, a machine, becomes to act like a human. And this is where a very important test called Turing test took place. This is where a method of inquiry in artificial intelligence for determining whether a computer can think like a human being. A computer can think like me. A computer can think like you. And exactly like this, say for argument's sake, exactly this way, if you see on the left-hand side, there's someone sitting on the computer, okay? And that is interrogating another person on the right-hand side. And in between the two, there is a screen. So the person on the left-hand side is trying to integrate the person on the right-hand side without knowing whether that person on the right-hand side is a human being or a machine. If the judge who is sitting on the left-hand side thinks that other person, the machine, is a human, the machine will pass the test. And chat box falls into that category. Chat box falls into that category. So, and it acts rationally. And this is an agent doing the right thing. The rational agent is the agent which is doing the right thing. It maximizes the goal achievement with the information that has been provided to that particular equipment. It does not necessarily involve thinking, but there is a feedback controller and there is an optimizing production. And I said it must think like a human. That means there is some way in which the information is being processed. So that is where cognitive neuroscience come in. It is the connectionist approaches which is inspired by this category. And as I mentioned, it must think rationally. It can't give stupid answers. That's where logic and mathematics comes in. That is exactly what Aristotle used to do. But not all intelligent behavior is mediated by logical deliberation. Not everything which is there in the world has got logic solution. So, in fact, what you see over here, what you see is that not everything which is there has got a logic solution. Now, the difference between a weak artificial intelligence and a strong artificial intelligence. A weak artificial intelligence is that which can solve real world problems. Even if the solution is not human life, but it can still solve the problem. A strong AI is one which thinks and acts like a human. Look at that. It thinks and it acts like a human. So it fantasies about AI, and that is what is called a strong AI. So it thinks and acts like a human being. So now, if you look carefully, I want to show you the difference between a human and a machine. If you look, computing has this capacity to process information, and they do that in different ways. They have speed. Several ways are there. They have speed, where transistors are much faster than neurons. Look at that. See that transistors are much faster than neurons, okay? Because they are operating in the nano range to picosecond range, whereas neurons typically fire in the millisecond range. See, one is in picosecond and the other is in milliseconds. So the neurons is much faster and it's very complex. We have been using transistors for such a long time that we know we can handle this, and we say that it's less complex, although it was complex once upon a time, but no longer so. So they are less complex than neurons, but it requires more energy. So, in fact, the machine requires more energy. The function transistors uses electrons. If it wants to, if it wants to alter their output based on input signal, neurons use neurotransmitters to activate or suppress signaling based on inputs from adjacent neurons. And then the other facility is size. The human that you have has got a biological neurons, and it ranges between 4 to 100 microns, whereas artificial neurons can be much smaller. And then we know about the difference between analog and digital. Most chips operate in a binary on and off mode, whereas some chips mimic the activity of different ion channels by flowing current through transistors in an analog fashion. Despite all these differences, neurons and transistors can often be combined. Example could be, let us say, for argument's sake, a brain-like computers can use micro and nano optoelectronic devices and can simulate the characteristics of a biological neurons and synapses. So mimicking the brain with single transistors like an artificial neuron was only discovered in 2022, on 28th October 2022, when it was noticed that since the human being consists of about 10 to the power of 11 neurons, it is necessary to develop highly scalable artificial neurons. And that's what we have done. So you can see they have much stronger computing, they have much stronger storage, and naturally computing time is much stronger. Where is 10 to the power minus 3 seconds, and the other one is 10 to the power minus 9 seconds. So therefore, you can see the machine has become much more smarter than a human being. And if you look at it, when you're looking at artificial intelligence and uh, machine learning, one of the best examples I can think of is a autonomous vehicle. You know, you've got a lot of electric vehicles. Nowadays, you have electric vehicles which can not only store energy, but it can supply energy if required. There's enough power within it, but enough control has been built in where you can use it. Not that it was used very much, but it's an autonomous vehicle. You do not need to have a driver in the car. You do not need to have the you can have a stage, and a stage will come when we will be driving autonomous vehicle, go to our office, and it's very difficult to find a parking space in CBD. So the car will automatically go and go and park somewhere about 20 kilometers away. And when I need the car, I dial some number and it'll automatically come and pick me up from my CBD. So there's enough autonomous vehicles are there. The capacity in the electric vehicle has gone to that much. And there is, in any car nowadays, you can see facial recognition, speech recognition, virtual assistant, forecasting, medical diagnosis. Most of the things are available. I mean, I have an old car, which is a Volkswagen 2022 model, okay? And my Volkswagen has got facial recognition. I don't need to put any key. It recognizes my fingers and it opens it as soon as I touch the handle of the car, of the door. Virtual assistants are there. It keeps on telling me things. It keeps on forecasting the weather. Medical diagnosis I don't have in my car. So let us see some of the terminologies. My first terminology I want to introduce is machine learning. You keep on hearing about machine learning. This is a form of artificial intelligence and it enables a system to learn from data. So you do not need explicit programming. Data is what is captured. So data is king, my friend. And that is where it learns. Machine learning uses various algorithms, and that iteratively learns from data to improve, describe data, and predict outcome. And there are the supervised learning, classification, regression, and the supervised learning has got the unsupervised part and the reinforcement learning. The unsupervised learning is clustering, associations, anomaly detection, sequencing, recommendation, and market-based analysis. The reinforcement learning learns from trial and error, like a robot in a maze. And many people are using RLL, the reinforcement learning language. One of my PhD students who had just finished, he used RLL for hydrogen generation and the pipeline to commute hydrogen from Perth to Melbourne, 5,500 kilometers. So the machine learning has the ability to learn from data. You don't need to do any programming. The data itself will be enough. So it can go beyond the initial program. And as I mentioned, there could be supervised learning, there could be unsupervised learning, and reinforced learning. The supervised learning gives you the classification and regression. Unsupervised learning gives you the clustering and pattern finding. Reinforced learning gives you the agent interaction and the environment so that it can maximize the information. So let us see. This is how the supervised learning takes place. That is the data which is there, okay? And it is saying who is the founder of Apple. Apple is the organization. I'm not talking about Apple, the fruit that you have. And it comes up with a solution. So in the supervised learning, which is the regression scheme, there is input-output training set which is given. Like I can train it in such a way that the day is Monday and at 10 a.m. on Monday and the month is February. And you understand if you are in northern hemisphere, the temperature over there would be 4 degrees Celsius. Naturally, in Australia, it wouldn't be, but I'm taking for granted many of you are from the northern hemisphere. The temperature in January, February is very, very low. And at that time, the electricity demand is 1450 watts. Again, on another Monday, again in February, the temperature is 5 degrees Celsius. This time, instead of 1450 kilowatt hour, the demand is 1410. And another day, when the temperature is 10 degrees Celsius, the demand is 1380. So one can find a function that estimates the output for a new entry. Again, the new entry is again Monday at 10 a.m. in February, and the average is 7 degrees Celsius. And at that time, you can find what is the demand of electricity. That will be anything between 1380 kilowatt hour to 1410 kilowatt hour. The supervised learning is where the forecasting is done, where you do the pricing models, you look at the performance model, and you look at the weather, and then you can predict your weather pattern. Or you can do the regression learning, which is the time series analysis, where you can see the production, like the economic forecasting of the production which is going on, and you can predict what the market is going to look like at that time. The unsupervised one, where the clustering is being done, again, I have got some examples. I have chosen 4 human subjects. The 4 human number 1, the height is 180, mass is 80, Human 2, height is 160, mass is 53. 3, 190, mass is 70. Human 4, height is 167 and mass is 56. I can cluster this into two groups. I can make both the 180, 190 into one group and 160 and 167. That is, I can cluster the human 1 and human 3 into one group and human 2 and human 4 into other group. So I can cluster 1 will have human 1 and human 3. Cluster 2 will have human 2 and human 4. If, say, for argument's sake, and this is unsupervised learning, I've got 9 subjects over here, look at that, and I want to put them into various groups. Look at all the blue-collar people, look at all the blue-collar people person, this one, right, then this person and this person. I can cluster them into one group. Look at all the people who are the business tycoon, this person, and this person. And the graduates that I can see, and I can put that as a graduate, I can put that as a graduate, and I can put that as a graduate. So you see that I can cluster this into various groups, my friend. It's an unsupervised, but 9 of these people can be clustered into 3 groups, depending on their classification. The knowledge. This is where decision trees come in, ontologies comes in, question and answer comes in, and this is where the diagnosis is there. So you find that you can actually look at that and have a representation of the knowledge by using different types of tools that you have. The reinforcement learning, as I told you, I'm working in RLL at the moment, where the agent is interacting with the world and the agent is observing what is happening and it is performing the action, and every action which is being done, the agent is punished or encouraged. So you say, well, very good. The agent, you say, if there's something gone wrong, and you, the agent. So the agent must make sure to have the maximum encouragement if you want the agent to be successful. Now, building an artificial intelligence system. And if you look at a supervised system, I see that I have got this 7 process. You gather the data, you pre-process the data, and you label the data. Look at that labeling data. I'll come back to that in a minute. Look at that. I want you to observe that labeling data. And the rest of them, from labeling data, you select your feature, you train your model, you evaluate and deploy it. In the unsupervised model, I replace the data labeling. I replace that with feature selection. Pankaj cannot see the slide, Shiposho.
Yes,
Pankaj
Professor
cannot see
Kalam.
the slide. Can others see the slide, or is only Pankaj which is not seeing the slide?
I do believe it might be his network connection. I would advise that he leave the
Pankaj has
session and
got
join
technical
again.
issues, Shiposho. Pankaj
Yeah.
has got, so it's not our problem.
Rest assured,
Pankaj
we
has got
will
his
send the
own
recording
issues.
to
I'm
him.
sorry, Pankaj. Douglas can see the slide. You can see the slide, so it should be all right. I'm sorry, Pankaj, I can't help you.
We'll send you the recording, no problem at all.
No
You
problem.
should receive it
So look
today.
at that. The difference between the supervised one and the unsupervised one is that cluster where you do the feature selection or you have done the data labeling, or else it is exactly the same. Look at that. Thank you very much, Bakazi, for telling us that. Look at that. When you do the reinforcement, the step is much less. Where you still do the deployment, but here you've got different blocks to bring you to that stage. Therefore, it's a much faster system than the other two. Now, this question is asked to me at many times. People ask me this question. What are the technologies that we use? Very hard in 50 minutes to tell you all the technologies and all the nitty-gritty of it. I can only cover a basic fundamental thing. There are so many technologies that one can use and techniques that one can use. The most common one of them are the ANN, which is artificial neural network, the KNN, which is the K nearest neighbor, then the support vector machines, the Gaussian mixture model, the hidden Markov model, expectation maximization, K-means clustering, and genetic algorithm. We have been using genetic algorithm for a long time. I have been using genetic algorithm for the last 20, 30 years in my power system studies. So, but that has been with the coming of machine learning and artificial intelligence, that strength has been enhanced. So if you look at the artificial neural, which is the most commonly used one. So you've got your input layer, which has got hidden and the output layer. This is the neuron and this is a synapse. And that's your output layer. Now, if you look at it, in the ANN, you have all these input, which goes through the Jacobian, and there is a function of transformation. And that's the equation that you're trying to solve. And you solve that equation. Again, you can look at the KNN one. Look at the KNN one. The K nearest neighbor one. If you look at that, you find that this is the one which it finds that that is the nearest neighbor to that particular object. The tools that you would like to use, and I would strongly suggest you use this tool, although there are a lot of tools, I say because I'm a very much a strong power engineer and we have not used this before, but I strongly suggest use Python. Please use Python. Although Python has got Scikit, TensorFlow, use whatever you want to. There is other tools like Vika. There's MATLAB, which has been used for centuries, and cloud-based one like the IBM Watson, the Google Machine Learning, the Microsoft Azure, and Amazon Machine Learning. But my suggestion to all my students nowadays is to use Python. As I said, in Python, you've got TensorFlow. This is an open source library which is there for machine learning. It's a very complex model. So any complex model that is there can be used with this TensorFlow program. And you can see that if you want to. I've given you the website. The Vika, which is there, this is open source one. And without the GUI that is there. And I've given you the suggestion for that too. MATLAB, everyone has used. It's very common. Every university uses MATLAB. And the reason they all use MATLAB, because they just have to use one platform and they can use for engineering, business, law, anything you want to use it for. That's why they use it. Although Python is a billion times better than MATLAB. And nowadays, if you want to go for a job in the utility, they will ask you whether you have any knowledge of Python or not. And those who are the thank you very much. Thank you very much, Pankaj, for responding. MATLAB is very commonly used by engineers and scientists. So in summary, I can look at the gamut of the things like Python, MATLAB, R, Vika, Cloud, you name it. Okay, C++. I'm from before C++ time. I'm from Fortran time. So things have completely changed. And you can draw a thing by looking at whether you have experience on it, whether you need flexibility, whether you need MATLAB experience, whether you need R experience, whether you need experience in programming, whether you need GUI solution. Depending on what you need, you use that type of platform. And as I told you, although Vika can do with people that have got no experience in programming and they want GUI solutions, right? but you might find that Python might be a better answer. Okay, case studies, and I want to do some case studies that I want to do today. Remember, my friend, at the moment, we are just scratching the surface. We're very far from general AI, but specialized AI can be used if you have the data. I'm talking about real data, and this is a problem that we engineers have. We have data, but how do you know it's good data? I cannot distinguish. I've got millions of data that I generate in my the simulation lab that I've got. I cannot distinguish what is the good data, what is the bad data, what is the hopeless data. So you have to have a proper data, my friend, and real-time data we are talking about. You need to make predictions, and you need to use operation optimization for operations and control. So you can use chatbot, and let's use RNN. Okay, chatbot says that, "Hi there, where were you last night?" You can say, "I was in the bathroom." "What's your name?" "My name? Oh yes, your name, please." "My name is John." "How are you today?" "Fine, I'm doing great." "So, do you like to go out with me?" "Sure, I like you." Right? "And I love you, you know that." And he says, "I love you too. Let's go grab a beer. Come on, I gotta go now." Can you see how the chatbot had tried to do the conversation using R and N? And this is one thing that I use a lot, okay, using smart grid. And big data is what I keep on talking about, especially when it is for a large and complex as a utility, where we are talking about a whole gamut of data sets that I've got, which cannot be actually processed with traditional data processing application software. Remember, I've told you I need real-time data. So real-time data from the smart grid could be generated in terabytes because it's a massive scale in the power grid. So, as I mentioned, I have built my own substation, okay, and I do the measurements over there, and I compare with the field measurements that is actually obtained in the substation. I can do the feeder intelligent electronic devices. I use intelligent electronic devices, IEDs, so that I can get devices which has got specified commercial or government databases. I can look at weather data of different types. I can look at lightning detection data. I can look at seismic data. I can look at electricity market. I've got so many things. So I can define it in two categories. I can put in two nests. One is internal data I've got, the other is external data. Internal data is the meter data that I got from my meter, my PMU, which is phasor measurement unit, a PLC gives you my power line monitoring data, etc. Whereas the external one, which I have no control, is the weather, social network, I have no control, stock market, it keeps on fluctuating. So question which I'm asked, what can machine learning do in power system? It can predict failure, my friend. It can tell me where the failure is going to be, when it's going to be, how it's going to be. It can provide me protection against this outage. Naturally, if there is an outage, especially in a grid these days, you can lose millions of dollars of money. Then it can be a dynamic energy management system, especially if you are looking at demand response, peer-to-peer electricity trading, etc. So you can do demand side management. You can detect theft. Cyber theft is another one, which is becoming a very big issue. Then there's predictive maintenance. You can do real-time customer billing. The customer is interested in real-time billing. You can optimize asset management. You can enhance customer experience. You can look at the demand and renewable forecasting, and you can look at condition monitoring. All these things we are doing at the moment. using data engineering and data science. The demand side management, where we have set up measures that use the load and local generation to support the network. And this improves the quality of power supply. So you can have a direct load control, you can have emergency demand response program, or you can provide ancillary services. And this is how our local energy and market operator, Australian energy market operator, does the demand side management. You can do energy forecasting. If you are looking at appliances in a house, you can extract useful information. I mean, nowadays you've got fridge, which is a five-star fridge. It tells you cheese is finishing. So I go and buy cheese that I can replace. Eggs are not there anymore. Nowadays, they're specialized. There's special type of five-star fridges available that you can do that. You can see that there are few questions. Okay. When do they work? How far are they from work? How can they commute? How do they do things outside the work? What do they do? What do they do at home? And therefore, I can actually look at my monthly energy demand. Okay. That is what my forecast demand is based on the previous month. Whereas other demands are the blue colored one, the dotted one, the hashed one. Peer-to-peer energy trading, this is becoming very important, especially if DG is involved and energy storage is there. Remember that nowadays you do not have consumer, you have prosumer. So those people who are producing electricity, they are also consumer and they're also selling electricity. So this type of peer-to-peer energy trading, where the agent is a prosumer who produces and consumes energy, exchange with other prosumers in the neighborhood and supplies the extra or surplus electricity that is overproduced by this person after consumption. Instead of wasting it, I always believe sell it to your neighbor rather than selling it to the grid. Nowadays, in any case, selling it to the grid is of no value because they don't give you anything back. The feed-in tariff is absolutely not valuable anymore. So you can do the peer-to-peer trading in stock exchange, where you try to maximize the gain by trading at the optimum time. You know, the peak time when you have to do that. That is a time when the market price of stocks will fluctuate in real time. So you can see that you can evaluate the difference in electricity trading, and you can look at the electricity reserves, which can change in real time when not traded. The actual trading volume is related to power losses. These are the various type of condition monitoring that you can do. So you can do all these condition monitoring as a time series. You can look at again condition monitoring, whether it's supervised or unsupervised, whether it's classification or regression. If it's classification, will the equipment fail or not within a period? If it's a regression, what is the remaining helpful time for this equipment? If it's clustering, does the wind turbine data fit the usual way? Predictive maintenance. Did you know about DBScEng? This is demand-based spatial clustering of application with noise. Lot of noise around there. So remember, sound is very complicating. It complicates, it brings in noise factor, which can completely comes in a form which can disguise the actual data and can bring in a lot of uniformity. Look at this, where you can see a trusted data point based on the density. So this is what you need to do. Then what else can we do? I use only the smart grid example because I natural language can process and smart grid strategies are working. It can look at a survey of the participants. It can do predictive control. It can do optimum power generation distributions among various power sources and storage systems. And it can look at the health status of equipment, which is purely based on appearances. So this is some of the example of some of the power station. This is in Hornsdale, where we looked at the price forecasting for battery usage forecasting. Then I want to talk a bit on IoT. As I mentioned, let us use Google. And I said, AI is the intelligence of machines or software, as opposed to the intelligence of human or other animals. It's a field of study in computer science that develops and studies intelligent machines. Such machines are called AIs. But according to Wikipedia, IoT describes devices which has got sensors. Can you see that? Which has got now sensors. It has the processing ability. It has the software and other technologies that connect and that connects and that the IoT, which I'm talking about, has got sensors, processing ability, software, and other technological things which connect and exchange data with other devices. So it keeps on talking between each other over the internet, over communication network. This IoT consists of electronics, communications, computer science, engineering, etc. IoT has been considered a misnomer because devices do not need to be connected to the public internet. They only need to be connected to a network, and they are individually addressable. So, for utilizing AI and IoT in electrical system monitoring, you can enhance efficiency and safety. You can provide real-time data. You can look at it as a decision-making tool, and they will fulfill the business needs. So you can also see that AI and IoT can improve your efficiency and improve your predictive maintenance of power system. And as I told you, it can give you safety. Safety is a very big factor nowadays. Occupational health and safety has become a very big factor nowadays. And we need, I told you, definitely has a lot to play in electrical system monitoring. And it has an impact. You can look at remote monitoring. Many times nowadays, power system which is there, it does not require any monitoring from anywhere. You can be in any part of the town. You can be sitting in a nice beach somewhere 200 kilometers away from the power station and still control your power station. It's cost saving, okay? It gives you the safety, it provides you better resources for that you can do planning, and it improves your efficiency. And then I've given some examples. I think I'll skip these slides because you'll get that slide. I don't have the time to complete all this, but I can definitely tell you it's finding dramatic use in the power systems. And as Chipuchu has written, that please ask your questions if you have any. I'm trying to go forward. It seems that it's not allowing me to do that. Uh, uh, and I've given you all the examples that I can think of, okay, giving you all the differences. But I can definitely tell you this has become a very strong tool, AI and IoT, especially in connected and autonomous vehicles, in smart security for power station, power networks, homes and businesses. When you integrate household appliances with IoT, there are smart digital meters for power system repair and maintenance. There's machine-to-machine connection devices. There's transportation routes and supply chain. You can use it for physical inspection of power and transmission line by drone technologies, and in energy as well as in building a smart city. Future research, and I leave that to you. That is something which will be very important for you to remember, that we are going in the world of computer, quantum computing, where you'll be looking at cryptography, etc. In the energy area, I'm looking at exploration of renewable energy sources and optimization of energy. I'm using n number of things, and you can read one of my paper, which is decarbonization of Australian economy, that was published last year, very well appreciated by everyone in the industry, and it talks about what's going to happen to the power system in 20 to 25 years time, where there'll be energy mix that'll be there, and you don't have to be dependent on only solar or wind or anything. There'll be gamut of energy thing, and you will have to make the best utilization and optimize for the best use naturally. So my friends, the future is definitely going to be IoT and AI together. And innovations are definitely there in computing, quantum computing. But you must remember, integrating AI and IoT will bring a new space for discovering insights into the next generation provisions. With that, I have completed my presentation. Okay, I leave it now for Chipurchu to talk about the other stuff.
Thank you so
Chipurchu
much.
is all that yours.
Yes, are you able to hear me, Professor Kalam?
Yep.
Thank you, everyone. I really do hope you enjoyed the presentation. As we've mentioned, you are now free to ask questions. However, as I've asked in the beginning, please do mention that you have a question in the chat box or the Q&A section. And then once I know you have a question, I will be able to give you presenter rights, and then you can ask your question to the professor live. So once you guys are compiling your questions, I will go through the following slides. If you are interested in the Doctor of Engineering program, please note that we have 2 intakes that are available for the 3rd of March. So we have the online option, and the start date is going to be the 3rd of March. However, please note, because the DEng program is something that is really important, it is an AQF level 10, there is a deadline for you to complete your application in time. You'll also need to provide an essay and provide additional documents in order for your application to be reviewed by the admissions team. So you need to apply in due time. I will be able to provide you with the course schedule links. However, everyone is going to receive a recording as well as the PDF slides. So you can click on any of those hyperlinks, go straight to the application, or rather the website. You will be able to apply for the program. For the on-campus course, it is set for March again. However, I don't believe the time is great to apply for on-campus. Rather, apply for the second intake. The visa processing will take a long time if you are away. So if you're not interested in studying online, I would say that you would need to apply for the second intake of our DEng program. I see we have Pankaj, you have a question. Would you like to ask a question to the professor live, or
Yes,
would you?
I can answer that. Give me 1 minute,
Sure.
please. It's a
No
very
problem.
nice, it's more than a question. It's a very nice observation. This is Pankaj. Pankaj says that he 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 recently was in one of the faculty workshop on machine learning and artificial languages from Florida, which was funded by NSF, which is National Science Foundation, and that was for a biology course. But now he finds that it has further enhanced his understanding, and the examples I gave him at least gives him an indication of where AL and ML can be used. Both the AL and ML can be used in engineering application. I gave examples of engineering application and how, I must admit, there are so many examples that it is not easy, but I can definitely tell you, you need to sit down, and I can assure you of this, and those of you who got a bit concerned and were not sure what I was talking about when I said that Python is the language to go for. By the way, I don't get any commission for you buying Python. It's just that I want to tell you, one of my students, his name is Alan Butler. Okay, he works in the gas industry, and he's working in hydrogen project with me. He he was um, very uncertain whether he should be using Python or not. And I convinced him to use Python. You wouldn't believe it. It took him only 1 month and he became an expert in Python. Only 1 month it took him. And I can assure you, it is not a big deal, okay, that using these type of things is going to be hard. I can assure you, Pankaj, you are very right that I have given you applications, I've given you understanding, but till the time you do not spend your time and actually work in it, you may not be able to do you can't do justice to the program. So artificial learning and machine learning are very, very important thing. Artificial intelligence and machine learning, and I can tell you right now that this is the future, my friend. I did tell you, although in Australia, the government services yesterday announced that DeepSeek will not be allowed in the government offices in Australia. So no government offices in Australia can use Deep Seek, which is a deep learning platform. And I can assure you, this is a wonderful platform, DeepSeek, and it goes much beyond chat box. And I must tell you that I have not tried it out, but what I've read, I can assure you that it'll go much beyond chat box. And the government is concerned about other political matters rather than the in engineering matters, and we are concerned about engineering only. And if you look at from the engineering point of view, it definitely can do a lot of wonders. I hope, Pankaj, I have responded to your comments, and thank you very much for that comment. Um, so yes, as you rightly said, used it. Um, um, I think we have got courses, Pankaj, that are utilizing both AI and ML, and as a this is not part of the of promoting the DEng program, but we've got everyone has to do 32 hours of coursework element, and one of the coursework element is AI and ML. So you will find that some of the things, not all, some of the things that I mentioned will be taught in a class environment. And the way it is, a DEng program takes about 3 years, and literally 2 years is research, and 1 year is coursework. And the coursework element, one of the subject is AI and ML. Any other questions, please? Any other comment? Thanks, Pankaj, for your great comment.
Whilst we're still waiting for the people to ask their questions, should they have any questions, as Professor Kalam has mentioned in the beginning of the webinar, the Doctor of Engineering Toolbox chat happens every first Thursday of the month. These are upcoming doctoral webinars that you are able to register for. They will be available on our website. Lastly, if you could please either use the link or the QR code, scan it, and provide us with some feedback regarding what you'd like to see on the next topic. We do value your feedback and we take it into account once we develop new webinars or when we hold future webinars. I'm just going to wait for about a minute or two before I close the session if we do not have any questions. If you are interested in enrolling on any of our programs, please note that you're able to do so using the links that I will leave in the chat box. You can visit our website. I will also include the link to all our future webinars, and you can be able to register for those. They are available on the EIT website. lastly, if you are interested in speaking to a course advisor to discuss your study options, I will also leave a link there. You can book a call, and a course advisor from one of our teams will be able to call you and discuss all the study options you have regarding whichever program, even if it's not the DEng program. However, they will be able to advise you on the programs we have on offer at EIT. I'm just going to wait for another minute and see if we have another question. If not, thank you so much, ladies and gentlemen, for joining us. Hoping to see you on the next one. I will leave all those links I have mentioned in the chat box for your easy reference. Please note, even after I close the webinar and the chat, you are still able to access the links as well as the information that is left on there.
Right. Since you are, there's not many questions coming anymore, so I think it's time to pack up. Thank you very much for attending the 20 people who attended today's seminar. Please remember, next month I have literature survey strategies that I'll be talking about. Again, every topic, even last year I gave 10 or 12 of these presentations, and they were all different. And the reason is that so that it is basically to enhance your skill so that you can complete a Doctor of Engineering program in the bare minimum time. And I don't think that we are expecting people to be there in our Doctor of Engineering program for longer than 3 years. We want everyone to be finishing around 3.5 years time. Right? So with that, I'm finishing the seminar. Bye-bye. And thank you very much for your attendance. Thanks a lot, Magbogu.
Thank you so much, everyone.
Peter, give me 1 second, Peter. I'm just closing a seminar. Okay. Okay. Bye-bye. I'll see all of you. Okay. Thank you very much for attending this. And we'll hope to look forward to seeing you all on the first Thursday of March. Bye-bye.